Hello, this is Jennifer Dassinger with A Plus College Ready, and today we are in part 2 of our writing and naming compounds. Today we'll focus on molecular compounds and acids. A molecular compound is a covalently bonded unit of atoms or molecules. Now that word covalent simply really just means a mutual attraction for electrons, either equal attraction or an unequal attraction. There are two types of naming systems that we use for molecular compounds, the stock naming system versus the prefix nomenclature system. The stock system uses the elements or polyatomic molecules, oxidation numbers, and their state. So if you notice at the far right of your chart, you're going to see that the stock naming system uses the Roman numerals of the element that comes first in the compound. So if you notice phosphorus, Roman numeral 3, chloride. That Roman numeral 3 comes from the oxidation state of the phosphorus. The next example, phosphorus, Roman numeral 5, chloride. Again, we're only looking at the oxidation state of the first element of the compound, in this case, our molecules. Then if you notice, transition over to the prefix naming system, it uses the number of atoms of each kind within the molecule. So compare and contrast the first example, phosphorus. Notice the first element does not have a prefix. The first element does not have a prefix when it only has a subscript of 1. It's understood. But the second element will always have a prefix when it has an understood 1 to a number 3 or to number 10 actually. So if you notice again, phosphorus, trichloride, the word phosphorus is left alone because the 1 is understood. The 3 comes from the 3 atoms within the molecule. Skip down to another example and look at NO. I know, right? Nitrogen, again, no prefix for the first term. But the second prefix for the second element is added because that 1 has to be represented for the ratio of the second element to the first element. And mono is R1 prefix. If you skip back up to N2O, notice now, if our first element does have a subscript other than 1, it will have a prefix. And if you notice on the student notes, your prefixes are 1 for mono, 2 for di, 3 for tri, 4 for tetra, 5 for penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. The first 4 particularly are going to change depending upon our naming systems. 5 through 10 stay the same throughout all naming of our compounds and molecules. When we are writing and naming acids, first off, an acid is a substance that generates a hydrogen when placed in a solution. And this is our Arrhenius definition. There's several types of definitions for acids that we'll learn later on in another unit. The chemical formula usually begins with the letter H. There is an exception, and acetic acid. Acetic acid is an organic acid, and it can be written in 2 ways. It can be written as HC2H3O2, which represents the H in front that we recognize as our acid, or it can be written in a biological way in terms of the structural unit of CH3OOH. That is another version of its writing. So just kind of give you a heads up. There are 2 categories, if you notice. Looking at your chart, there are binary acids, which simply means 2 elements in the compound or molecule. And then there are oxyacids. And this is 3 or more elements, and one of those 3 will always, of course, have an oxygen in it. If you notice in our binary acid naming, we again use a prefix. And our prefix for all binary acids is hydro. And then the second element, which is also a nonmetal, typically a halide, but can be others such as cyanide. And if you notice in our example, chlorine is our second element. Instead of the INE ending, it then will change and turn an IC ending. So our example for the binary acid is hydrochloric acid. Pretty simple. Now we're moving on into our oxyacids. Does it start with the letter H? Then move down the diagram. If it has 3 elements, no hydro prefix. However, the ending of the polyatomic ion, yes, they're here to stay. We have to know our polyatomic ions, remember. The 8, if it's a polyatomic ion, will turn to ic. If it is an ite polyatomic ion, it will become an us. So in the example given to you for our oxyacid is H2SO4. You must look, yes, we have an H. We have more than 2 elements. Then I recognize that my SO4 is sulfate, therefore its suffix will change to an ic. So now my acid name is sulfuric acid. In the notes, you're going to see in the student notes that there are some categories of polyatomic ions that have multiples. And in these oxyacids, you have to use a prefix with them. So if I'm looking at HClO, that is hypo. Hypo is our prefix that we would use, meaning the lowest amount of oxygen. Chlorus, because ClO is chlorite. Hypochlorite. And then if you notice ClO2 polyatomic ion is chlorite, so my acid would be a chlorus acid. If I'm looking at a ClO3 polyatomic ion, I know that that is chlorate. So therefore my acid will be chloric acid. And finally, ClO4 is perchlorate. So my name of my acid will have a prefix per. Again, the 8 ending will be to an ic, so it'll be perchloric acid. Don't forget, if it has multiples of the oxyacids, the polyatomic ion, then you're going to be using the hypo and per. Again, knowing those polyatomic ions will assist you in this help. Hope this video was helpful. Good luck in naming molecular molecules and acids.